Good morning, everyone. Thanks for inviting me, David and Claudia, and your hardworking team put this together. Last year, we worked together to create the first combined early detection of heart disease and lung cancer conference. And the presentations and the contents are available online. It left me with one conclusion, and that is, in order for the 30-some years of work that David and Claudia and you guys all have done in lung cancer screening, extending to cardiovascular disease and bone health and hepatosteatosis that Andrea beautifully presented, all of that to come to patient care, to come outside of this, what I call think tank room, a small group of brilliant people that develop new ideas. In order to make it an impact on patients' life, on people's life, improve outcomes, longevity, we need to move from this stage to a trial stage. So that was my conclusion from last year's meeting. And I suggested to David and Claudia that the next meeting should focus on that. And then we came to this conclusion that we should hold that as a separate meeting, and it will be in November 6th, at the American Heart Association's annual conference dedicated to this topic, which I'm going to show you. But what's the topic? I think everybody is familiar: to get the best out of a chest CT to improve outcomes. The big killers, as you know, heart disease or cardiovascular disease, number one, followed by lung-related and liver cardiometabolic, including bone health or osteoporosis, are key contributors to mortalities. So we outlined this 5 years ago, and I met David and Claudia to go and use AI to extract this information, but not just to publish paper, which I'll show you, we've done quite a few, not just to come here and give lecture, but actually take it all the way to the FDA and make it available for patient care. That's been my focus. And this is the group that have supported me. They're mostly cardiovascular, because in lung cancer screening, I mostly have David and Claudia and Tony. So this group has already, this is such a short amount of time, demonstrated that measurements done through a chest CT, a cardiac CT scan, or a chest CT scan is very comparable to everything else we do in cardiology, cardiac MRI and echo. So here is an MRI. The top one is a cardiac chambers volumetry report extracted by our AI. The bottom left is MRI. As you can see, you cannot see the difference in the middle when the AUC lines are. They're completely overlapped. MRI is a much more expensive technology. It would take you longer to acquire a cardiac volumetric measurements. Here, as an opportunistically, a cardiac CT or a lung scan shows the same results. That was for heart failure prediction. This is for a stroke and atrial fibrillation. As you can see, very much overlapping. LA volume measured in a lung scan or a cardiac scan, I'll show you cardiac versus lung next, predicts future heart failure, atrial fibrillation, and a stroke, similarly to MRI. Here's the echocardiography. This is the most recent one. And we show here on the left is the echo, and the right side is a regular CT scan, again, gated or non-gated. Interestingly, it does even better. As you can see, the separation here between these two is better than the separation between these two. And this is supposed to be measuring heart failure, all kinds of things related to heart failure. This is not. This is just an opportunistic finding. But look at the outcomes. On the left side is CT, on the right side is the echo. What you see, this red is the top quartile in either groups. What does it tell you? you have a very powerful technology, CT, in your hand with AI combined. This is another one where we're showing gated versus non-gated. You know, a lot of discussions in we have weekly meeting with David and Claudia and his team that are we going to get a similar results from a non-gated? Are we really sure? Well, this is data from MESA, multi-ethnic study of atherosclerosis. About 2,000, over 2,000 people had both cardiac and actually 3,300 some, both cardiac and lung scan. As you can see, the results are both for heart failure and a stroke. So bottom one is a stroke. The top one is that. And again, this is the top quartile in either groups. Additional items, this was one of the slides I think Suzanne beautifully presented. Myosteatosis. This actually happened between last year and this year, where we found that the muscle quality or amount of fat in the muscle can predict outcomes, again, from a lung cancer screening or a cardiac scan. And these are the two papers that are that just got accepted. This one predicting heart failure and AFib, and then the other one is predicting diabetes. Both got accepted for publication. So I asked ChatGPT to create a graph for me that shows the past. There was no lung cancer screening. Show me the present, and then show me the future, where comprehensive screening will come out. ChatGPT messed up. Osteoporosis is twice, but you can get the point. And I asked him to correct itself, and it messed up more. I said, well, this should be inside. Okay, finally you got it right. And we have now this approach going for future. So, but that's just a dream. David said a few minutes ago. But to make that dream a reality, we need this trial. This is the trial we'll be talking about at the American Heart Association meeting. I refer to it as LDCT mega trial. The idea is to use image guided. Here, image is LDCT treatment as one arm versus the status quo, which is whatever we have in cardiology, measure your blood pressure, cholesterol, diabetes, risk factors, and then whatever you have currently from U.S. Preventive Task Force Services, which is limited to a small portion of, not a small, but it's limited. It leaves out about around 20,000 people who have lung cancer, just like the former CEO of YouTube and passed away. This doesn't cover those. This will cover those. And so what are these components? Each of these are targeted for particular abnormalities. If you find calcium score, based on the level of calcium score, you target them different LDL level. We have evidence for that, but we don't have trial. AI-CVD for if you find people with extreme features of vulnerability in coronary atherosclerosis, send them to cardiology. If their LV and RV is enlarged or left atrium is enlarged, and we're talking here about top quartile. So instead of getting the whole population treated, just the top quartile for this approach. And also, I'm not going to go through this. This conference will be live on Zoom, and we have David and Claudia and some of the Jim, Molshine, and Tony, and many of you have shown interest to participate. So let me just quickly go to the next topic. That trial is going to need multiple countries, multiple organizations, multiple sort of advocacy group from lung, liver, heart, bone to come together. And that's the proposal for this. We call this LifeMap. LifeMap has two sides, a system that we're working with GE and proposing to US government ARPA-H grant to help us build it, which is a unbelievable futuristic, but not too far from now, an autonomous CT where there is no human involved. You go in just like you're walking through the TSA security at the airport. That's LifeMap system, but the LifeMap Foundation is aiming to execute this trial. I'm not going to have time to go through all of that, but we've circulated this, and Claudia asked me to send it again. I'm going to do that. And this executive summary will outline what we plan to do. Let me just quickly walk through, say why this needs to be. So the study design will have a lot of discussions at the AHA meeting, but why this should be a nonprofit organization and why it requires multiple entities to come to a place. So you can read that here. And I think that's the key, that for the first time, we bring cardiologists, which we brought last year, cardiologists to your meeting. Now for this, we need more than that. Cardiologists, pulmonologists, liver people, bone people, they all come under one, that we built the guideline and the required trial that will dictate the future of cardiovascular medicine. So with that, I'm going to stop here. I wear two hats. This hat is under my SHAPE organization, Society for Heart Attack Prevention and Eradication. That's what fueled all of these AI-CVD studies. I also founded Heart Lung to make this happen, bring it to patient care. So there is a video about Heart Lung. They would warn me, do not make this a commercial talk. Well, I'm just going to give you the plain fact. If we don't take it to FDA, if we don't make it a patient care tool, it will stay in this room forever. And we need to do that. And that's just not enough. We need to do the trial as well. So this is about AI-CVD.
Every year, over 20 million chest CT scans and more than 80 million total CT scans are performed in the US alone. Now imagine transforming each CT scan into a powerful, life-saving tool that helps prevent disease, starting with the #1 killer, heart disease. At Heart-Lung AI, we've built AI-CVD, the first comprehensive AI-driven platform that detects early signs of cardiovascular and metabolic disease, all from routine chest CT scans. AI-CVD begins with our AI-CAC module, which automatically identifies and qualifies both calcified and semi-calcified coronary artery plaques, leading markers of heart attack risk. It also measures calcification of the aorta and aortic valves, key indicators of cardiovascular health. Our auto chamber technology detects chamber enlargements invisible to the human eye. It calculates heart chamber volumes and left ventricle mass, offering clinicians powerful insights into cardiac function. AI-CVD also measures the size of the aorta and pulmonary artery, revealing early signs of aortic aneurysm, pulmonary hypertension, and heart failure. Beyond the heart, AI-CVD assesses the entire chest, quantifying subcutaneous, pericardial, and visceral fat, as well as skeletal muscle health, providing a detailed picture of cardiometabolic risk. It evaluates liver density to flag silent fatty liver disease and measures lung density to detect emphysema-like or interstitial changes. Finally, AutoBMD, our bone mineral density module, screens for osteoporosis directly from thoracic vertebrae, providing instant Z and T scores. Together, these modules transform every chest CT scan into a comprehensive cardiovascular and metabolic health report, automatically and in minutes. But at heartlung.ai, we don't stop at the heart. Our Auto Lung solution, pending FDA approval, brings the same innovation to lung cancer screening. It analyzes the lungs holistically, identifying high-risk patterns, while our nodule-focused AI measures nodule size and characterizes malignancy risk, helping clinicians catch lung cancer early and manage follow-up with confidence. With heartlung.ai, hospitals and imaging centers can implement comprehensive, opportunistic screening and deliver proactive, personalized care to every patient undergoing a chest CT, not just those already at high risk. Join the future of preventative medicine. Visit www.provider.heartlung.ai to register for a free trial or contact us at contact@heartlung.ai to schedule a private demo. Patients can also visit www.patient.heartlung.ai to upload their CT scans, generate AI reports, and share results with their healthcare providers. Heartlung.ai, where innovation meets prevention.
Thank you for your attention.